So let's start with exponential notation. So exponential notation, this is the definition. If A is a real number, and real number means, positive, negative, could have decimals, fractions, and N is a positive integer. So your exponent, which is the superscript above your number, that is called the exponent, and that has to be a whole number. It's positive. Then a to the n equals a times a times a n times. So it's basically repeated multiplication. So n is called the exponent, a is called the base. And so that's read a to the nth power. Certain ones, like if it's a 2, it's a squared. You can have a cubed, and then a to the 4th power, 5th power, and so on. So there are several properties of exponents, and I'm going to demonstrate how to use all of these. I recommend having these handy, printed out somewhere, just so that you have access to them. The most common ones I'm going to highlight here. So property 1, where if you're multiplying things with exponents, the exponents add. Property 2, where when you're dividing, the exponents subtract. When you have negative exponents, it means you're taking the reciprocal to make the exponent positive. Anything to the 0 power is 1. Exponents distribute. And then if you have an exponent times an exponent, those are multiplied. And so basically all of these are important except for 8. We don't really deal with 8 very much. So all of these are actually really important. And then there's examples that you can see how these are used, and I will go through these as well when I go through my examples. Okay, so important thing is knowing how to do these on your calculator and enter them in the right way. So it's not incorrect, in the correct way. Because if you don't put it in your calculator correctly, you could get the incorrect answer, especially when you have exponents that are involved with negatives. So if you have a negative number in parentheses with the exponent outside, you need to put parentheses around that. If you don't, it will give you the wrong answer. And to get exponents, we use the caret symbol that I've just highlighted, and that's the same way you can write exponents if you're typing. You can use that caret symbol. It is above the 6 on the keyboard. So that's how we indicate exponents. So make sure that you are putting that in calculator correctly. Basically, if it's a negative number and it's in parentheses and it has an even exponent, your answer better be positive. If there's a negative number in parentheses and it's an odd exponent, you're going to get a negative out. So it's important to know those rules so you can also look at your answer and say, oh, wait, this is not the right sign. Okay, so let's go to actually doing some examples here. So evaluating exponential expressions. So I'm going to start just using the properties of exponents and showing you how these work. So evaluate each expression. So we have 3 to the 3rd to the 0 power. So our rule for exponents says if you have a power to another power or exponent to another exponent, you multiply those. You multiply the exponents. So that is 3 to the 3 times 0. And 3 times 0 is 0. So that's 3 to the 0 power. And then we have another rule that says if you have something in the 0 power, that is equal to 1. So that whole expression there is equal to 1. The second one here is negative 3 squared. So this is a very common one that people get wrong because the negative is not included in this square. So this is negative 3 times 3, if you want to think of it that way. So we're not squaring negative 3, we're squaring 3 with a negative outside. So 3 squared is 9, so your answer here is negative 9. The next one, I have 3 over 3 to the negative 4. So if you have something without an exponent, we always assume that exponent is 1. So that's 3 to the 1st power over 3 to the negative 4. Now, if we have something divided here, they have the same base. When you're dividing, the exponents subtract. And it's always subtracting top minus bottom. So this is 3 to the 1 minus negative 4. Now, if you're subtracting a negative, that's same as adding. So that is 3 to the 1 plus 4. So that is 3 to the 5th power, which I don't know what that is. I only know up to 3 to the 4th. So it'd be 81 times 3, 243. So if you wanted to evaluate that, that would be 243. Now the last one here. So we have 48 times negative 4 and then to the 3rd power. So you have to do the exponent before you do any multiplication. So I have to do the negative 4 to the 3rd power. So a negative in parentheses to an odd power means I'm going to get a negative answer out. And I'm going to put parentheses to show that I'm multiplying my answers. And 4 to the 3rd is 64. So that is 48 times negative 64. Now that is something I'm not going to do in my head. So 48 times negative 64. I know I'm going to get a negative answer. That is negative 3,072. And I'm just going to double check 4 to the 3rd is 64. Yep. So evaluating means you are finding the answer. That's what the word evaluate means. And so when it says evaluate each expression here, we're finding the answer. So evaluating, find the answer. And it's usually by following order of operations and rules of exponents. Okay, I'm just kind of squeezing that into my screen there. Okay, so that's evaluating exponential expressions. Now let's evaluate an algebraic expression. So algebraic means that we've got variables involved. That's the difference between regular exponential. These are also exponential, but they are exponential algebraic expressions because there's variables. So when you're evaluating something with variables, you first have to plug in a number to that variable, and then you evaluate like we did on the last slide. So then you're following the order of operations and that whole business. So this first one, we're given x is equal to 4. So I'm going to rewrite this. That's 7, and then x to the negative 2. So I always like to put my variable that I plug in, whatever that answer is, in parentheses, especially if there's negative involved, because that prevents any possible errors for, multiplying or dividing, and maybe you actually subtract it because it's a negative instead of multiply, that sort of thing. Okay, so I have 7 times 4 to the negative 2. So 4 to the negative 2 doesn't really make sense if you're trying to do it mentally. We want to use our properties of exponents, where if you have a negative exponent, you take the reciprocal. So that is going to be 7. I'm only taking the reciprocal of the 4, what's under the exponent, not everything. So that becomes 1 over 4, and then the exponent becomes positive. So then the exponent is now 2. So now I have 7 times 1/4 squared. So when we have an exponent outside, you distribute it. So that's to the inside, 1 squared over 4 squared. And so 1 squared is 1. So that's 7 times 1/16. And then when you multiply, you get 7 over 16. And then you would reduce if possible. And this one does not reduce. Now our second example here, we have 2x cubed, and we're given that x is equal to negative 3. So we have 2 parentheses negative 3 cubed. So a negative odd power means my answer is going to be negative. And 3 cubed is 27. So that's going to be 2 times negative 27. And that gives me a negative 54. So we always do the exponent first. Okay, now this last one, we've got a negative and then our x. So this one's a little confusing. So I've got 12 parenthesis negative, and then I'm going to put parenthesis, x is negative 1/3. So I got to make sure I close all my parentheses, and then the 3 is on the outside. So following the order of operations, we need to simplify inside the parentheses first before we do the exponents. So negative 1/3 cancels. So that is 12 times positive 1/3 to the third power. So I'm going to distribute my exponents. 12, 1 to the third power, 3 to the third power. And then 1 to the third power is still 1, so this is 12 times 1 over 27, which then, when you multiply, becomes 12 over 27. And that does not reduce. So evaluating algebraic expressions, you need to have a number for your x or your variable. You plug it in, and then you follow the order of operations like we did on the previous slide when we're doing evaluating. Okay, so now moving on, properties of exponents. So if you're not given a number for x, then you can't evaluate because you can't come up with a single number. So you can only simplify. So you're going to still follow the same rules we've been following, but you're not going to necessarily get rid of the variable. You're just going to kind of work as far as you can to simplify, which there's no solving. We're not solving anything. We're not going to get a number for x. We're not going to get x equals anything because there's no equals here to start with. We're just following the order of operations and the rules of exponents to simplify. So this first one here, I've got simplify each expression. We have in parentheses negative 2x squared. So that, because we have more than one inside the parentheses, we're more than one thing. We have a negative 2 and an x. We're going to distribute. So that's negative 2, that's going to get the square, and x, that is going to get the square. So a negative is going to go with our number there. Now, negative 2 squared, so it's a negative to an even power, so that's going to become a positive, and that's going to give us a positive 4, and then we get an x squared. So that simplifies to 4x squared, and we can't do anything else because we don't know what x is. Second one, same thing. You're going to distribute the power. So we have 4 to the 0 power, and then x cubed to the 0 power. 4 to the 0 power is 1. And then I need to multiply my exponents 3 times 0, so I'm going to write that out. So that is 1x to the 0 power, and that's equal to 1. Because anything to the 0 power is 1, so this just comes out to 1. And you can figure that out actually from the very beginning because the whole thing is to the 0 power, so that's just going to become 1. All right, now the last one here. We have 7, and then we need to simplify. We have x squared over x cubed. So the rule is to subtract exponents, top minus bottom. So I got 7x to the 2 minus 3. So 2 minus 3 is negative 1. And now we don't like to have our answers with negative exponents, so I need to take the reciprocal to make that exponent positive. And the 7 doesn't have a negative exponent, so the 7 is not involved. So this becomes 7 times 1 over x, which then becomes 7 over x. And you can kind of do that another way by saying, okay, if I have 2 x's on top and 3 on the bottom, if I start canceling things out, I'm going to have a 1 left on the bottom. So that's another way to kind of think about it and get that answer. Okay, so now I've got 3 more, and these are more complicated. These are the last 3 I'm going to do. So hopefully I can give you, my goal in this is to give you a wide variety of the types of problems with the properties of exponents. The best way to get good at these is just lots of practice. And so it's better for you guys to practice rather than me just do tons of problems for you. You're not going to learn that way. Okay, so first one, again, we're simplifying. We have 12 And then in parentheses, x plus 3 to the third over 9, and then x plus 3, x plus y, and then over 9 times x plus y. So same rules. So first off, we got 12 over 9, which we can reduce. So I can divide those both by 3, which gives me 4/3. Now, the base is x plus y when I'm looking at my exponents. And if there's no exponent, it's a 1. So this is going to be 3 minus 1 because I'm going to follow the rules of exponents where you subtract. And that will give me 4/3 times x plus y to the second power. And then that is simplified. You could multiply x plus y out if you want. I'm not going to worry about that right now. Okay, the second example, we've got lots of things going on. I always try to distribute exponents before I do any reciprocal stuff because of the negatives, and work inside out. So first we have something in parentheses to a negative exponent. So I'm going to first distribute that. And so that is going to be x squared to the negative 1 power. And then we have y to the negative 2 to the negative 1 power. And then my negative 1 on the outside with the bracket there. Okay, so we multiply these exponents to simplify them. So inside brackets, I have x to the negative 2 and y to the positive 2. And then same process, you distribute again. And I'm actually, because I'm sort of running out of room here, I'm going to just write that we distribute. So those are going to be multiplied so that I can just do that in one step. So we have a negative 2 times negative 1, so that gives us x squared. And then y, we have 2 times negative 1, so that is negative 2. And now we need to have, we don't want to have a negative exponent. So that y to the negative 2, we're going to take the reciprocal. And generally what happens is that means it goes in the denominator. Because we saw that with the 7 times x to the negative 1. So this will give us x squared over y squared. I would show more steps if I had given myself more room. That is a failing on my part. I underestimated how much room I would need. And I'm probably going to do the same thing on the bottom, so I will do my best here. So this last one, I've got 5x squared 6 to the 6 in parentheses cubed, and then 5x squared z to the 6 parentheses to the negative 3. Okay. Now notice that inside these parentheses, you have the same thing. So this is a special little trick that we can do. This is not always going to work. But I can basically see those are the same thing. And because they're the same thing, the exponents add. 3 minus 3 is 0. And if it's to the 0 power, it's 1. So we are going to get an answer of 1. But I want to show you how to get that the other way following our rules of exponents. So that starts by distributing your exponents. So everything 5 gets the 3, 5 cubed, and then I'm going to, because I'm anticipating running out of room, I'm going to multiply my exponents together at the same time. So 2 times 3 is 6, so that's x to the 6th. And then z, 6 times 3 is 18. And then I do the same thing with the second one, 5 to the negative 3. And then x, 2 times negative 3 is negative 6, so that's x to the negative 6. And then z, 6 times negative 3 is negative 18, so that's z to the negative 18. And now, when we're multiplying things, you want to combine the like things together and you add the exponents. So on the 5, 3 minus 3 is 0, so that's 5 to the 0. On the x, 6 minus 6 is 0. And on the z, 18 minus 18 is 0. And then all of those are 0 exponents, and that just gives you 1. Sometimes you don't get 1 with that. Most of the time you don't. This is a special case where you get 1 because it turns out that everything basically cancels out. So hopefully it's a very, well, as brief as I could be. It's still 20 minutes long. but to at least give you a wide variety of problems here to see with the exponents. So hopefully this is helpful. The best way to learn and get used to the rules is just lots of practice. So I recommend doing lots of practice problems and having your rules of exponents or properties of exponents next to you so you can refer to those. Hopefully this was helpful for you guys. All right, bye.